Welcome to Task 5 of Math is an Art. Before we start our number sense routine, it is time for your teacher to assign you your art partner. Press pause, then press play when you are ready to continue. Before we start our number sense routine, let's review our hand signals. We use these hand signals to communicate our thoughts during a number sense routine. These signals are held in front of your chest. A fist means I'm thinking about it. A thumbs up means I have an answer. And the last hand signal is how you show that you agree with something that someone else said. Today's number talk comes from the book Number Talks, Fractions, Decimals, and Percentages, written by Sherry Parrish and Ann Dominic. Look at this image. Can you see one half of the whole? Share how you see half of the whole with your art partner. Press pause when you are ready to continue. Press play. Let's look at the image again. Can you see half of the whole a different way? Allow for some think time before you begin answering. Once you are ready, discuss this question as a class. Your teacher will illustrate your thoughts. Press pause when you are ready to continue. Press play. Now let's look at this image. Can you see one half of the whole? Share how you see half of the whole with your art partner. Press pause. When you are ready to continue, press play. Let's look at the image again. Can you see half of the whole a different way? Allow for some think time before you begin answering. Once you are ready, discuss this question as a class. Your teacher will illustrate your thoughts. Press pause. When you are ready to continue, press play. Let's look at one more image. Can you see one half of the whole? Share how you see half of the whole with your art partner. Press pause. When you are ready to continue, press play. Let's look at the image again. Can you see half of the whole a different way? Allow for some think time before you begin answering. Once you are ready, discuss this question as a class. Your teacher will illustrate your thoughts. Press pause when you are ready to continue. Press play. It is now time for our collaborative problem-solving part of the task. We will begin our task by taking a look at this painting titled Cakes. This picture was painted by Wayne Thiebaud in 1963. Wayne Thiebaud was born in 1920 and passed away at the age of 101 in 2021. Mr. Thiebaud enjoyed creating art from an early age. He studied commercial art in high school and continued his studies at a trade college. He started out as a cartoonist and graphic designer, but World War II took his career in a new direction. From 1942 to 1945, he served in the Army Air Force as an artist and cartoonist. After his time with the Air Force, he began to pursue a career in fine arts. He began to explore how he could incorporate bright colors and shadows into a series of bakery-themed paintings. The painting you see here is a result of this series of paintings. When asked what advice he would give to young artists, he said, "Work harder than you think you need to work. Work when everyone else stops. The students who stay after class, who come on days when they don't need to come, who do work outside, who ask more questions, those are the ones that are interesting. And that interest is what produces interesting work." Our learning goals for this portion of the task are to reason through problems and keep working to solve them, Explain my strategy and seek to understand others' strategies. Work with others to design and create artwork that has meaning and purpose. How do fractions relate to Wayne Thiebaud's cakes painting? Discuss this question with your art partner. Then your teacher will guide you in a whole group discussion. Press pause, then press play when you are ready to continue. A bakery named Pieces of Cake has this painting in their store. This painting is what inspired the name Pieces of Cake. The owner loved this painting and decided to sell cakes made of pieces of various flavors of cake rather than single flavor cakes. Here are 3 of the flavors that the bakery sells: confetti, chocolate, and strawberry. The bakery has pictures of the types of cakes they sell on their menu. Here are some examples. This cake is called the 3/8 cake. Why do you think the bakery named the cake 3/8? Turn and talk to your art partner. Press pause, then press play when you are ready to continue. This cake is named the 3/8 cake because it has 3 slices of cake. It takes 8 equal-sized pieces to make a whole cake. Therefore, the cake is named the 3/8 cake. In addition to the 3/8 cake, they also make a 6/8 cake and an 8/8 cake. As we see, the 8/8 cake is equal to 1 whole cake. We see the 1/8 piece 8 times. The bakery has now decided they want to offer 3 more options that are larger than 1 full cake, but less than 2 whole cakes. Today, you are going to help the bakery come up with plans for these new cakes. Your task for today is as follows. Create and design 3 new flavors of cakes. Create and make a display of the 3 new options. You and your partner will decide the size. However, the options must be larger than 1 whole cake, but smaller than 2 whole cakes. Name the new cake options. The bakery likes to keep the name of the cakes based on the number of 8ths. To name the cake, you must keep this in mind. Keep our learning goals in mind while completing this task. You will be reasoning through problems and working to solve them when you are creating your new cake options. You will work with a partner to create the new options. To work together, you must be able to explain your strategy for solving, as well as listen to and understand your partner's strategy. And lastly, your cake display serves the purpose to inform guests about their order options. As you decorate your new cake flavors, think about what feelings you want the customers to feel. All 3 cakes will be used in each display. Use your understanding of the color wheel to help you design these new cakes. Your teacher will give you guidance on the next steps. Press pause, then press play when you are ready to continue. Let's discuss the pieces of cake task. You were asked to come up with 3 new flavors of cake and to make 3 new menu options that were larger than 1 whole cake but smaller than 2 whole cakes. My friend created this representation and named it the 9/16 cake. Do you agree with the name of this cake? Turn and talk to your art partner. Press pause, then press play when you are ready to continue. I do not agree with this name of the cake. The denominator tells us the number of pieces to make 1 whole. In this case, it takes 8 pieces to equal 1 whole. The correct name would be the 9/8 cake. This cake is larger than 1 whole cake. 9/16 is smaller than 1 whole. Because I have 9 out of 16 pieces of cake, it would look like this. The representations and meanings of 9/8 and 9/16 are not the same. The denominator tells us the size of the piece, and in this case, we cannot say that eighths are the same size as 16ths. I created a menu item named 28ths. What would this look like? Does this cake follow the rule that it must be larger than one whole cake, but smaller than two whole cakes? Why or why not? Turn and talk to your art partner. Press pause, then press play when you are ready to continue. This is a representation of 28ths. This does not fit the requirements of the task because it is larger than two wholes. Now it is time for our whole group lesson. You will need fraction circles, Cuisenaire rods, and your art manual. Press pause so you can gather these materials, then press play when you are ready to continue. Let's begin with our fraction circles. Now find the fraction piece labeled 1/4. Why is this piece labeled 1/4? Turn and talk to your art partner. Press pause when you are ready to continue. Press play. This piece is labeled as 1/4 because this is one piece out of 4 pieces to make the whole circle. This piece is the size of 1/4 of the circle. Let's build the full circle using the remaining 1/4 sized pieces. As we build, count with me. 1/4, 2/4, 3/4, 4/4. What happens if we grab another fourth? You might have to work with a partner to continue building. How many fourths would we have? We would have 5/4. 5/4 means we have more than one whole circle. Let's continue to build with our fourths until we have 2 whole circles. 5/4, 6/4, 7/4, 8/4. I have a question. How many pieces do we have in all? We have 8 pieces. Why are we not counting these as eighths? Turn and talk to your art partner. Press pause when you are ready to continue. Press play. We are not counting these as eighths because the denominator tells us that it takes 4 pieces to make the whole circle. These pieces are the size of a fourth. As a table, I would like for you to build a model that is larger than 2 holes but less than 3 holes. As you build, count by the unit fraction. Press pause when you are ready to continue. Press play. I chose to build with halves. If I used 7 halves, did I build a model that is larger than 2 holes but less than 3 holes? Let's check and see. 1 half, 2 halves, 3 halves, 4 halves, 5 halves, 6 halves, 7 halves. I did not. I built a model greater than 3 holes, so this does not fit the directions. Now let's look at our Task 6 lesson notes in our art manual. Let's draw a model using thirds. With your fraction pieces, build a model using 5/3. Let's count as we build it. 1/3, 2/3, 3/3, 4/3, 5/3. How could we draw this model onto our Task 6 lesson notes? Discuss this with your art partner. Then, draw the model on your lesson notes. Press pause, then press play when you are ready to continue. There are several ways we could draw this model. I will begin by drawing a circle and partitioning it into thirds. Next, I will count by thirds and shade while I count. 1/3, 2/3, 3/3. I do not have enough thirds, so I need to draw another circle. I will also partition this circle into thirds. Let's continue counting. 4/3, 5/3. We now see that we have 5/3. We could also think of this as 1/3 plus 1/3 plus 1/3 plus 1/3 plus 1/3 to get 5/3. We see the unit fraction 5 times represented in our picture and in our equation. Our learning goal for our whole group lesson is to apply my understanding of a unit fraction to understand that a fraction with a numerator greater than 1 tells us the number of unit pieces. Now let's put away our fraction circles and look at our Cuisenaire rods. To begin, we will focus on the green rod. If the white block represents our unit fraction, what is the size of our hole? Turn and talk to your art partner. Press pause. When you are ready to continue, press play. Our hole is equal to 3/3. That means the white block represents 1/3 of the green block. If the white block represents 1/3 of our hole, and the 1/3 fraction piece represents 1/3 of a whole circle, would this white block be the same as 1/3 of the circle when we were using our fraction pieces? Why or why not? Turn and talk to your art partner. Press pause. When you are ready to continue, press play. It would not be. The size and shape of our hole changed. Therefore, the size of the parts are different because the size of the holes are different. Now let's look at the purple rod. Does the white block still represent 1/3 of our hole? No. Now it will take 4 blocks to build our hole. Let's build that. 1/4, 2/4, 3/4, 4/4. Now the white block represents 1/4 of the hole. The size of our hole changed. Let's build 5/4 using our Cuisenaire rods. You might have to work with a partner to build this. Let's count by fourths as we build. 1/4, 2/4, 3/4, 4/4. I need another hole so I can have 5/4. As a table, I would like for you to build a model that is more than 3 holes but less than 4 holes. You are welcome to change the size of your hole to a different colored rod. However, be sure to figure out what unit fraction the white block represents before you start counting. Press pause, then press play when you are ready to continue. I use the red as my hole. This means that my white block now represents the unit fraction 1/2. I used 6 white blocks to build my model. Is my model more than 3 holes but less than 4 holes? Let's check. 1/2, 2/2, 3/2, 4/2, 5/2, 6/2. No, that's not more than 3 holes. It's equal to 3 holes. I would need to add at least one other half to fit the rule. How many halves do I have in this picture? I now have 7 halves. We will now draw a model on our paper. Let's draw 9/6. To begin, we will draw a rectangle. This rectangle represents 1 hole. Next, we need to partition it into 6 parts. To help me, I like to partition it in half and then partition each half into 3 pieces. Since we're drawing by hand, it's very difficult to get them perfectly the same size, but the idea is there. Now let's count our parts and shade as we count. 1/6, 2/6, 3/6, 4/6, 5/6, 6/6. What do I need to do now because I still need 9/6? I'm going to have to draw another whole rectangle, partition it into 6, and now I can continue counting. 7/6, 8/6, 9/6. So this picture is a picture of 9/6. I would like for you and a partner to try to write this as an addition equation using unit fractions. Press pause. When you are ready to continue, press play. Okay, so for our addition equation, it's quite long, but we should see the unit fraction of 1/6 9 times. Which gives us our total of 9/6. Let's review our learning goal. Apply my understanding of a unit fraction to understand that a fraction with a numerator greater than 1 tells the number of unit pieces. For example, we now understand that 3/4 means there are 3 1/4 pieces. Or that 5/3 means there are 5 1/3 pieces. We know that 3/4 is less than a whole and 5/3 is greater than 1 whole. Now it is your turn to show your teacher what you have learned through this lesson. You will complete the Lesson 2 formative assessment. Your teacher will give you more information about how you will turn this in. Press pause, then press play when you are ready to continue. We have now reached the math workshop portion of our task. Our math workshop will have 4 stations. At the small group station, your teacher will work with you to continue the learning about fractions. At the independent task station, you will complete a task without the help of your teacher. You are welcome to work with your peers on this task. At the application station, you will apply what you have learned to a new situation. Collaborating and working with your peers is encouraged at this station. And you will play a game at the math game station. So for the game Build 2 Whole Cakes, you will need the fraction pieces from the fraction cake game. You will need a paperclip to act as a spinner. So each player spins the unit fraction spinner. Okay, I get 1/4. My partner is going to spin 2, and they have to get a different fraction. Okay, 1/8. So what's going to happen now is we are going to take turns spinning the spinner. So when I spin this iteration spinner, okay, it tells me that, remember, I spun 1/4 at first, so I get to use 4 iterations of 1/4. And so I'm actually going to build a whole cake with that. The goal of the game is to be the first player that builds 2 cakes. So I didn't put all 4 of my pieces down. However, if my partner were to spin and they got 0, well, they don't get to put any pieces down for that turn, and I get to spin again. Each player takes turns spinning a number of iterations until one player has 2 whole cakes built. The first player to get 2 whole cakes built wins the round, and the first player to win 10 rounds wins the game. At the end of the game, you're going to discuss which fraction was the best fraction to spin and why. It is now time to begin Math Workshop. Press pause. When you are ready to continue, press play. Congratulations! You have now reached the end of Task 5. See you next time with Task 6.